Even a slight change in the Earth's orbit could severely impact our ability to survive, since the position of our home planet makes it uniquely suited for life.
The Earth seems to be an ideal planet in terms of habitability because it lies at just the right distance from the sun, in which point liquid water can be stable on our surface. We can have oceans and lakes and rivers, and we think that water is really the key ingredient for life.
Earth is in that special zone. It's not too cold, nor too hot, it's just right. If we were closer to the sun, we might end up like Venus, a planet too hot to live on, with a temperature hot enough to melt lead. On the other hand, if we were farther away, we might be more like Mars, which is just ridiculously cold, and you can't support life when you're too far from the sun.
But what would happen if Earth's delicate balance were disturbed, so that it was no longer this perfect distance from the sun? Far beyond our solar system, there are planets wandering through the galaxy, not bound to the gravity of any star. Known as rogue planets, they were ejected from their birthplace by unstable orbits or cosmic collisions and sent on wild trajectories through the universe.
Essentially, a rogue planet is a planet that was originally in a different star system, and it was kicked out and is now wandering the cosmos, divorced from its parent star.
There's likely to be at least as many planets as there are stars. So we expect there's something like 100 billion stars in our galaxy, and so we expect a couple 100 billion of these rogue planets.
These rogue planets are interstellar nomads, cold, devoid of life, and careening through the darkest reaches of space. And many of them are likely to be giants, hundreds of times larger than Earth.
Right now, we're seeing more so-called Jupiter-sized planets than others. Based on that, you could expect an average rogue planet to be on the order of a Jupiter-sized planet, maybe less.
With billions of rogue planets in our galaxy, it's possible that one could swing through our solar system with monumental effects.
A rogue planet coming into the solar system will probably be moving at hundreds of miles per second.
It's possible that a rogue planet could hit the Earth directly, completely demolishing our planet. But a rogue planet would not even have to get near the Earth to create havoc.
The nightmare scenario is that one of these large rogue planets drifts right through our solar system and ends up disturbing the orbit of one or more of the larger planets. And because these larger planets, like Jupiter, actually help shepherd the inner planets, it ends up elongating the inner planets' orbits, which would dramatically change things for life on Earth.
It's almost like taking a baseball bat to the Earth, the rogue planet being the bat, and just the force from this planet will be so great that you just change the path of the Earth just in the same way that a bat can change the path of the baseball on its way to the catcher's glove.
And if Earth's orbit were elongated just enough to swing outside the habitable zone, our very survival could be at stake.
The habitable zone, as we understand it in any star system, is defined by what we call the triple point of water. You find water in all three phases: liquid, solid, and gas. And so far as we know, you need that in order for life to be able to survive. And when you start making Earth's orbit more elliptical, you start touching the fringes of this habitable zone where it could be a little warm for all three phases or a little cool for all three phases. We're still there, but it doesn't take much to shove a planet's climate over the edge and either make it a super hot Venus or lead it to a very cold Mars.
Since there has never been an encounter with a rogue planet in recorded history, scientists are unsure of how the event would play out.
So we really can't know with great certainty what is going to happen if a rogue planet comes into our solar system. We can run computer models, we can make educated guesses, but at this point it's a purely hypothetical phenomenon.
Here is one possible scenario. A rogue planet suddenly appears on the fringes of our solar system. As the rogue streaks past the outer planets, the whole solar system begins to change. The rogue's gravitational pull alters the orbit of Jupiter. Jupiter, in turn, pulls the Earth out of its nearly circular orbit to an elliptical orbit.
If it passed near the Earth, then the Earth's orbit would be changed almost instantaneously.
This new orbit takes the Earth as close to the Sun as Venus and as far out as Mars. Although we still remain in the habitable zone in this new elliptical orbit, our climate would begin to alter drastically. For most, the change is so gradual that at first, it's hardly noticed. The days grow longer and the nights get colder, but life goes on as before. But over the next few months, a slow-motion global disaster begins to unfold.
There's a common misconception that the Earth's seasons are driven by our distance either toward or away from the sun, where summer is when the Earth is closest to the sun and winter is when it's farthest away. That's not true. Right now, it's the Earth's tilt that causes summer and winter. So when your side of the planet's facing toward the sun, it's summer. And when your side of the planet's facing away, it's winter.
The entire planet would have summer at the same time because it's very close to the sun, and then the entire planet then experiences winter at the same time when you're farthest away from the sun.
So the Earth would enter a new climate phase where you would have short but intense summers and then very long winters.
So life on Earth is very much dependent on the orbit we are in around the sun.
The shift in our seasons would wreak havoc on Earth's agriculture, resulting in a shorter growing period and eventually mass food shortages.
The effect could be very dramatic and really affect the prospects of life on Earth. If we're very unlucky, it could end life on Earth.
As the climate catastrophe continues, the Earth struggles to adapt, and the worst is yet to come.